Okay, this is a picture of an artificial neuron, um, and we have some inputs here, and then we have an artificial neuron, a single artificial neuron here. And the way this works is we have these inputs, x1 through xd. You can have more than one input, so just x1 to many inputs. And when we're talking about an image, we'll have all the pixels will be a separate input, so you have a lot of pixels, you have a lot of inputs, and in fact, if you have a color picture as opposed to grayscale picture, then for each RGB, red, blue, green, RGB, red, green, blue, you'll have a separate channel, so you have 3 channels. For for each pixel, you'll have 3 channels instead of 1. The way this works is we take some weights and we multiply each input by a weight. And these weights are usually set randomly. Sounds kind of strange, but that's the way it's done. And then we also have a separate node input here, in addition to these, which is always 1, and then has a weight b assigned to it. So these are always variable depending on the image, or depending on, well, let's say image. Depending on the image, you're going to get, of course, different pixels, so you're going to get different inputs. But this one is always going to be 1. We set this up to, it's called the bias. And it's kind of equivalent to, well, here's the equation in vector form of what we're going to get in here, what's going to be sent to this node. And if we don't think of it in vector form, just think of it as a regular equation. So this is like y equals b plus something times x. So like this is usually the slope, right? So y equals b plus mx, right? Then that the m is the slope, and b is the y-intercept. Without that, you'd have everything going through the origin, which makes things a little bit less flexible. So we like to have one term that is allows us to not go through the origin, basically. And that's this is filling the same role here. So anyway, okay, forget about this for a moment. So we have these inputs, and we have this. So these inputs, x1, x2, all the way up to xd, the last one, can be expressed as a vector. And then multiplying, I want to multiply x1 times w1 and x2 times w2 and xd times wd and so on. So that is equivalent in vector notation as to set all of these as a vector and then do the dot product with another vector of the weights. Now, instead of writing the dot product, if I take what's called the transpose of that w vector, then I can say it's not the dot product, but just the matrix product. So we can also write it like this. If we either write it as the dot product or the matrix product. But if we write the matrix product, we have to put the little t up here to mean the transpose. So it basically just means what we just said, which is you take wi times xi, in other words, you take w1 times x1, plus w2 times x2, plus w3 times x3, That's all this, which, as I said, can be written like this, if you call them vectors, and then plus b. Okay, so that's called the and sometimes it's called the pre-activation of the neuron. So that's the pre-activation means what goes into the neuron, but neurons also have an output, and hopefully the input is different than the output, otherwise it's useless to have them. So we're going to have an input, and then we're going to do something to it to get an output. So the input can sometimes be called the pre-activation before you activate the neuron. Before you activate it. Then you activate it means you take the input and do something to it to get a new output. So this is called the pre-activation value. This or this or this is called the pre-activation, or the input activation. And then the output, or the output activation, you do something to the input. So this says you take the input activation, which is here, you put it into some G, and you get an output. The whole process, starting with X, the whole process is called H. But it really means just take the input, put it into some other function, which we haven't decided what function that's going to be, but it's going to be some kind of function, and then we'll get an output. So W here are the connection weights. It's a vector. V is the neuron bias. It's not a vector, it's just a value. And G is called the activation function. This outer function here is called the activation function.